This meeting is being recorded.
Problem 1.5, we will solve similar to 1.3 and 1.4 in the sense that we're going to consider valency of each of our atoms. In order to determine, we're told here that there are 4 constitutional isomers. So that's our answer here. We're going to have 4 structures with the chemical formula C3H9N. So we're going to draw the Lewis structure for each of these isomers and then determine the number of lone pairs on the nitrogen atom in each of these. So we can begin by placing everything in a chain here. So we can connect our nitrogen to our carbon, to our other carbon, to our other carbon. And this is because we know that carbon is tetravalent and nitrogen tends to form 3 bonds and have a lone pair. So we'll start off our drawing like this and connect our nitrogen in a chain with our carbons. And then we have 9 hydrogens to fill in here. So remember, each of these single bonds represents 2 valence electrons. So we can have a structure like this, and then our nitrogen would have the other 2, so it would end up with 1 lone pair. So this is the first of 4 structures. Next, we can start with a carbon, and then put the nitrogen next, and then have carbon, carbon. So that would result with, if we filled in 1, 2, 3, 4, 5, right, all 9 of these hydrogens, we would end up with 1 here as well, and then a lone pair on our nitrogen again. So that's 2 out of 3, and then we can also have nitrogen in the middle, surrounded or bonded to 3 carbons, each of which carbon has 3 hydrogens, so we get our total of 9 hydrogens. And then that leaves the nitrogen to again have a single lone pair. The last structure would be if we have all 3 of our carbons in a row and then the nitrogen coming off as a side chain. So let's fill in our hydrogens here around the carbons. So there'll be 3 on each of the end carbons, 1 on the middle carbon, and then we see our nitrogen would have 2 more because we only had 7 there, and then that will leave a lone pair. So all of the nitrogens have the same number of lone pairs, 1.